All right, so with this section, we are going to go ahead and solve exponential equations. We start off with this piece here. Now, the idea behind all of these pieces that we're going to be doing is when the bases are the same, all we need to go ahead and do is look at the exponents and know if the same bases are there that the exponents have to be equivalent. So this one was already set up for us. But when I get down here for the next one, this has a base of 2 and this has a base of 16. So I have to go through and rewrite that. 2 stays as 2 to the 3x minus 8. And I rewrite that 16 as 2 to the 4th power. Now, once I get there, I know that my bases are the same, so therefore my exponents have to be equivalent. And I just go through and solve this equation. What I have here is 3x minus 8 must equal 4. I go ahead and add my 8 to both sides. And then I have 3x is equal to 12. Divide both sides by 3 and I get x is equal to 4. Now, if you see what we do here, if we go through and plug this in and we go through and check this, what happens? What we have is we have 2 to the 3 times 4 minus 8, or 2 to the 12 minus 8, which is equal to 2 to the 4th power. Now, if you first look at this next example here, we see the 8 and the 4. They both have the same base, even though it's not obvious when we first look at them. What we want to do is rewrite this as 8 is 2 to the 3rd power. Now, we have to remember that when an exponent is raised to another exponent, we end up multiplying them. Oops, I got the wrong thing here. I went ahead and I wrote a and x. That really should be x plus 2. And then over here on the other side, 4 is 2 squared, and all of that is being raised to the x minus 3 power. Now, what that means is I have to go through and multiply the 3 times everything and the 2 times everything here. So what I end up getting with this is 3 times x plus 2 is equal to 2 times x minus 3. Make sure you distribute. And you are left with 3x plus 6 is equal to 2x minus 6. Go through, subtract 2 from both sides, and I'm going to be left with x. I subtract 6 from both sides, and I'm left with x is equal to negative 12. All right, I'm going to go ahead and move on to the next section here, and we're going to talk about what happens when the bases are different. And when the bases are different, we must go through and use logs. All right, so there's several different ways that I can go through and look at this. I'm going to give myself a little bit more room because I want to give you 2 different ways to solve this first one. All right, so if I'm starting to look at this, there is no way that I can go through and turn 4 and 15 into the same base. So what I want to do with this is I want to go ahead and change into log form. I do that by saying this is log base 4. That's that base that I have up here with piece. Remember that 4 is a smaller subscript of 15 is equal to x. Now, That absolutely is a correct answer. This is an exact solution. Some of you will have calculators that can go ahead and turn that directly into an approximate solution. If not, what you're going to need to do to find the approximate solution for x is use the change of base formula, and that will be the log of 15 over the log of 4. For most instances, all you're going to need to do with this is give 4 decimal places as your maximum answer. So if you plug that in the calculator, what you end up getting here would be 1.95344. So if I want to go through and round this to the 4th decimal place, want to round it to here, so I look next to it, that 4 is not larger, so rounded to 4 decimal places, this would be a final answer. Now, one way that you can think of doing this is you can go ahead and think about this. Whenever you only have one term is equal to one term, and this is key, it must be in this case. You can also think about these equations is if you have 4x is equal to 15, is you can think about them as taking the log of whatever base that you want is equal to the log of, again, of whatever base you want. But this only works when you have 2 different terms like this. So an example of how to do this is, because my base here is 4, I will go ahead and take the log base 4 of 4x is equal to the log base 4 of 15. Now, if we remember this identity property, the x comes in front, log base 4 of 4 is just all equal to 1, so x is just equal to the log base 4 of 15. Same answer as we got before, it's just 2 different ways of looking at this. All right, let's go ahead and do the same thing for this question. So what I have here, again, I want to change this. This is equal to, this is my base here. So because e is my base, I must use the natural log. Log base e is the natural log. So what I have here is the natural log of e to the x is equal to the natural log of 0.854. And this is that idea of using, taking the log of both sides. This x comes in front, and I'm also left with x. Remember, the natural log of e is my identity property. All of that is just equal to 1. So x is equal to the natural log of 0.854, which you can leave like that, or if you want to go ahead and turn that into a decimal approximation, the natural log of 0.854 rounded to 4 decimal places is going to give me a negative 0.1578. You get exactly the same thing as if you change into log form. That is log base e, which is my natural log, of 0.854 is, oops, I ran out of room, so I'm just going to put my equals to x over here. Both ways work. Let's go ahead and take a look at one more of this type of question. Now, with this type of question, it's really important to go through and get the base and the exponent all by itself on the same side of the equation. And we'll simplify it if we do this first. So the first thing I'm going to want to do is go ahead and take both of those and divide by 1,000. When I do that, you're left with e to the negative 4x is equal to, now that is 75 over 1,000. I want to go ahead and simplify that. 75 over 1,000 is the same thing as saying I have 3 over 40. All right, so at this point in time, I'm going to use that same idea of taking the log of both sides. And again, I can do that because I have one piece is equal to the other piece. When I have that, I can go ahead and now say I have the natural log. And I'm using natural log because my base is here, is e, of e to the negative 4x is equal to the natural log of 3 over 40. Give myself a little bit more room here. That negative 4x comes out front, so I have negative 4x is equal to the natural log of 3 over 40. And to solve for x, I just divide both sides by negative 4. And this is your final answer in exact form. If you are looking for your answer in approximate form, just go ahead and put that in your calculator. Make sure you use the natural log here. So natural log of 3 over 40 is equal to negative 2.5902671. And then I'm just going to go through and divide that through by a negative 4 for my answer, and that will give me a positive 0.6475. Now, because this next piece here is a 6, I'm going to round this up and make that a 6 for my final answer rounded to the 4 decimal places.